Hello, hi everyone. Welcome to the Student the Brand. This is our Swasa. Today topic is light reflection and refraction. Today topic is light reflection and refraction. So, what is light? Light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. When light incidenting on the surface, it reflects back. It bounces back. Okay. So the bouncing back of the light from the reflecting surface, the bouncing back of the light from the reflecting surface is called reflection of light. It is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. So incident ray, reflected ray, normal light. Incident ray, reflected ray, and normal light. So here you can see a reflection of light, uh, reflection and refraction. Light, reflection and refraction. Light reflection and refraction. Light reflection and refraction. So here you can observe. So I'm taking the plane surface. Are you understanding? I'm taking the plane surface. Plane surface is nothing but, so this is the plane surface. This is a plane surface. One side is reflecting surface, another side is coated. One side is reflecting surface, another side is coated. Okay, so the bouncing back of the light from the reflecting surface, reflection of light, reflection of light, reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Okay, so this is the incident ray, reflected ray. So incident ray and reflected ray. The line which is perpendicular to the plane surface, the light ray which is perpendicular, we are drawing with the dotted lines. Are you understanding or what? We are drawing with the dotted lines. Yes or no? So here I am drawing with the dotted line. So this is called normal. Normal. Okay, so normal. The light ray which is perpendicular to the plane surface is called normal. So incident ray and reflected ray, incident ray, reflected ray, and so normal. Okay, incident ray, reflected ray, normal. And the undeviated line, the light ray which is, so here it is moving, so this undeviated line, incident ray, reflected ray, normal line, undeviated line. The angle between incident ray and normal line is called angle of incidence. So this thing, angle of deviation, angle of incidence and angle of reflection, angle of incidence plus angle of reflection plus angle of deviation, So here you can observe, so the linear angle, so this is a linear angle is 180. How much? Linear angle is 180 degrees. Linear angle is 180 degrees. So that is nothing but, here you can observe one thing. So this is the linear angle, angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Yes or no? So angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. I hope it is very clear. So okay, fine. So I can understand. Now, so you can observe one thing. Laws of reflection. So we'll discuss about laws of reflection. So laws of reflection. Laws of reflection. Laws of reflection. So here you can observe, coming to laws of reflection. Laws of reflection are nothing but, So incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Point number one. Point number one, incident ray, reflected ray, normal line lies on the same plane. So point number two, angle of incidence is equal to angle of reflection. Once again, incident ray, reflected ray, normal line lies on the same plane. So, and one more thing, angle of incident is equal to angle of reflection. Okay, so now you can observe from laws of reflection we can write angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. Okay, so now angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of incidence. So then angle of deviation equal to 180 minus 2 angle of reflection. So why you are taking here, instead of here angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. So the same thing, angle of, instead of angle of incidence, if I write angle of reflection, I'll get angle of deviation equal to 180 minus 2 angle of reflection. I hope it is very clear. So this is about angle of incidence and angle of deviation and loss of reflection. So now we will discuss about regular reflection and irregular reflection. Regular reflection, when so incident beam is parallel, then reflector light rays are also parallel, then this type of reflection is called regular reflection. Coming to irregular reflection, incident light rays are parallel but reflector light rays are not parallel to each other. That type of reflection is called irregular reflection. Irregular reflection. So this is about once again, the bouncing back of the light from the reflecting surface. The bouncing back of the light from the reflecting surface. The bouncing back of the light from the reflecting surface is called reflection of light. Reflecting back of the light from the reflecting surface is called reflection of light. Incident ray, reflected ray, normal line. Angle between incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. Angle between reflected ray and undeviated line is called angle of deviation. Okay, so I hope it is very clear. Coming to laws of reflection, incident ray, reflected ray, normal line lies on the same plane. And the second one, so angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So angle of deviation equal to, so here you can observe from here in this point. So instead of angle of reflection, if I substitute angle of incidence, we'll get angle of deviation equal to 180 minus 2 angle of incidence. And here if you substitute instead of I, if you substitute R, we'll get angle of deviation equal to 180 minus 2 angle of reflection. So this is about angle of deviation, loss of reflection. The bouncing back of the light from the reflecting surface is called a reflection of light. So I hope it is very clear. It's clear. So now, if the light ray is passing along the normal line, if the light ray is passing along the normal line, so what is the angle of incidence, what is the angle of reflection, and what is the angle of deviation? Can you tell me if you know the answer? If the light ray is passing along the normal line, if the light ray is passing along the normal line, if the light ray is passing along the normal line, what is the angle of incidence, what is the angle of reflection, what is the angle of deviation? Right? Tell me. So now, na 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 So I am taking the plane mirror. This is the plane mirror, plane mirror, plane mirror, plane mirror. So incident ray, if the light ray passing along the normal line. So plane mirror I am taking incident ray along the normal line. What is the angle of incidence? What is the angle of incidence? What is the angle of reflection? What is the angle of deviation? Can you tell me? Point number 1, point number 2, point number 3. So, if the light ray is passing along the normal line, what is the angle of incidence? What is the angle of reflection? What is the angle of deviation? Can you tell me, anyone? So, here, angle of incidence. Normally, the angle between incident ray and normal line. So, if you are taking this normal line, So the angle between incident ray and normal line is called angle of incidence. Angle between reflected and normal line is called angle of reflection. Okay. So here angle between incident ray and normal line is called angle of incident. Angle between reflected and normal line is called angle of reflection. And the deviated line. So here you can observe this. See, angle between reflected ray and initial direction of the incident ray is called angle of deviation. Yes or no? Okay. So here you can see. So the light ray is passing along the normal line. Light ray is passing along the normal line. Then angle of incident is 0 because so light ray is passing along the normal line. The angle between incident and normal line is called 0. So if it is passing along the normal line, so there won't be any angle, right? So that's why angle of deviation, angle of incidence is 0. And angle of reflection also, because if the light ray is passing along the normal line, it reflects back in the same direction. So angle of reflection also 0. And what about angle of deviation? Angle of deviation is 180 degrees. Angle of deviation is 180 degrees. How can you say angle of deviation is 180? So here, this is the reflected ray and the initial direction of the incident ray. So I am taking here this angle of deviation 180 degrees. So angle of incident is 0, angle of reflection is 0, angle of deviation is 180 degrees. So this is about if the light ray is passing along the normal line. If the light ray is passing along the normal line, so welcome back here. So you can observe here. So yes, electric current I will explain. So after completion of this one, I will try to explain electric current. So already we started this one. So just so do like, share and subscribe and follow my channel. So electric current also I'll explain. Okay, done. Come to the point. So here incident ray. So angle of incident is 0, angle of reflection is 0, angle of deviation is 180 degrees because so here you can observe. So incident rays and incident ray and reflected ray will be in the same direction, opposite. So it will be in opposite direction but in the same path. Okay. So incident ray along the incident ray direction. So I am taking this initial direction of the incident ray. So here you can see reflected ray and initial direction of the incident ray. That angle is called angle of deviation. So reflected ray will be like this. So initial direction of the incident ray, then the angle between that is angle of deviation is 180 degrees. So I hope it is very clear. So angle of incident 0, angle of reflection is 0, angle of deviation is 180 degrees. 180 degrees. I hope it is very clear. This is about if the light ray is passing, if the light ray is passing along the normal line, if the light ray is passing along the normal line, angle of incidence is 0, angle of reflection is 0, angle of deviation is 180 degrees, angle of deviation is 180 degrees. So what is regular reflection? Regular reflection. And what is irregular reflection? So regular reflection is nothing but, so I am taking here, this is a plane mirror, plane mirror, plane mirror, plane mirror, plane mirror, regular reflection, regular reflection, regular reflection. So here incident light rays are parallel, incident light rays are parallel, then reflector light rays are also parallel to each other. Incident light rays are parallel, reflector light rays are also parallel to each other. This type of reflection is called regular reflection. So incident beam is parallel, then reflector light rays are also parallel to each other. So this type of reflection is called regular reflection. This type of reflection is also called regular reflection. Incident beam is parallel, then reflected beam also parallel. Incident beam and reflected beam. This type of reflection is called regular reflection. Coming to irregular reflection. Irregular reflection. So irregular reflection takes place on rough surface. Irregular reflection takes place on rough surface. So I am taking here this is a rough surface. Incident light rays are parallel, but reflected light rays are not parallel to each other. Incident light rays are parallel, but reflected light rays are not parallel to each other. This type of reflection is called irregular reflection. This type of reflection is called irregular reflection. So here you can observe these are incident light rays. Incident light rays. Incident light rays. These are incident light rays. So reflected light rays are not parallel to each other. Incident light rays are parallel, but reflected light rays are not parallel to each other. This type of reflection is called irregular reflection. Irregular reflection you can observe here. So this will go in this direction, this will go in this direction, and this one is going in different directions, and this one is going in different direction. Okay, so those are moving in different directions. Okay, so incident light rays are parallel, but reflected light rays are not parallel to each other. This type of reflection is called irregular reflection. This type of reflection is called irregular reflection. So here you can observe regular reflection and irregular reflection. So regular reflection, incident light rays are parallel, then reflected light rays are also parallel to each other. This type of reflection is called regular. Coming to irregular reflection, incident light rays are parallel, regular reflection, but 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 reflected light rays are not parallel to each other. Okay, so here regular reflection takes place on smooth surface, plain mirror, and still water. What about irregular reflection? Irregular reflection takes place on rough surface. Example, wall and paper also. On paper also irregular reflection, and wall also irregular reflection takes place. Now, regular reflection completed, irregular reflection completed, reflection of light is completed, and loss of reflection is completed, and angle of deviation formula is completed. What about object and image? Real object, virtual object. What about object and image? So let's start discuss. Okay, object and image. So this is about regular reflection, irregular reflection. Now object and image will discuss. Object and image, object and image, object and image. Object and image, object. So I'm taking the plane mirror. This is a plane mirror. This is a plane mirror. So I'm taking here. So light rays are coming from. So here I'm taking the light rays. This is one light ray, and this is one light ray. After reflection, these light rays are meeting at one point. After reflection, these light rays are meeting at one point. So if you are extending these incident light rays, so image is, so there light rays are meeting, extended incident light rays are meeting. There you can observe, here what is this one? Real image. What is this one? Virtual object. Real image and virtual object. Real image and virtual object. So I'm considering plane mirror, plane mirror, plane mirror. So here the point, from here light rays are coming after reflection. After reflection, those light rays are moving away from it. Here, what is this one? Real object. What is this one? Real object. Real object. real object. If you are extending the reflector light rays, these reflector light rays are meeting at one point. These reflector light rays are meeting at one point. These reflector light rays are meeting at one point. What is this one? Real object. What is this one? Virtual image. What is this one? Virtual image. Virtual image. So now you can see here. So you can observe incident ray 1, incident ray 2, reflector ray. Reflector light rays are meeting directly at one point. Reflector light rays are meeting at one. Reflector light rays are meeting at one point directly. That is a real image. That is called real image. Okay, so here you can observe. So we are extending the incident light rays. Extended incident light rays are meeting at one point. There virtual object, there virtual object, virtual object, virtual object. Here is virtual object. So directly reflector light rays are meeting, that is called real image. Extending incident light rays are meeting at one point, that is called virtual object. Extension, either it is incident rays, either it is reflector light rays, either it is incident light rays, whether it is reflector light rays. Extension means it is virtual object. Extension means it's a virtual image. Yes. So here you can observe, these are the extended incident light rays. Extended incident light rays are meeting at one point. There. That is virtual object. I hope it is very clear. Now you can observe here. So from here, from this point, light rays are coming. So this is a real object, the source which is giving the light rays, the object which is giving the light rays. So from here, after light rays are coming after reflection, those are moving away from the principal axis. So extension of reflector light rays. Extended reflector light rays are meeting at one point. Their virtual image is forming. Their virtual image is forming. Their virtual image is forming. Extended reflector light rays are meeting at one point. That is virtual image. I hope it is very clear. Now you can observe here. Now you have to observe here one thing. Object is real, image is virtual. Object is virtual, image is real. Object is real, image is virtual. Object is real, image is virtual. Object is virtual, image is real. So this is very important. Very important. Very important. You have to understand one thing, you have to observe one thing, you have to be focused. Focus on this concept. Object is real, image is virtual. Object is virtual, image is real. So here you can observe incident ray, after reflection those light rays are meeting at one point. So that is real image. The point of intersection of reflector light rays is known as real image. The point of intersection of reflector light rays is called real image. The point of intersection of extended incident light rays is called virtual object. So the point of intersection of extended reflector light rays is called virtual image. The point of intersection of extended reflector light rays is called virtual image. So here you can observe reflector light rays, we are extending, those light rays are meeting at one point. Okay, so here this is the virtual image, real object. So here object is real, image is virtual. Object is virtual, image is real. This is very important. Very important. So keep in mind. Next one. So next one we are going to discuss about plane mirror, nature of the image formed by the characteristics of the image formed by the plane mirror. Characteristics of the image formed by the plane mirror. So I'm taking the plane mirror like this. This is a plane mirror. Plane mirror. How many light rays are required to form the image of the object? Can you say me how many light rays are required to form the image of the object? Minimum 2 light rays. Minimum light rays are required to form the image of the object. How many? Minimum 2 light rays. One light ray I am taking like this. Another light ray is incidenting on it. It will be reflected back. So just now in the previous example I explained here, you can see this is a plane mirror. If the light ray is incidentting along the normal line, it will be reflected back in the same direction. So if the light ray is passing along the normal line, it reflects back in the same direction. So here also same thing you have to observe. If the light ray is passing along the normal line, it reflects back. And here you have to observe one thing. Here also you have to observe one thing. It reflect back, it reflect back, reflect back, reflect back. So here you can see, 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 you can see object, object, object. Object, you are extending, 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 extending. Here also I'm extending here. So here, this is the reflector light ray extended. This also reflector light ray extended. So here image is formed. This is the image. What type of image it is? Virtual image. Why we are calling it is virtual image? Because reflector light rays, extended reflector light rays are meeting at one point. So here I'm taking here. This is A dash, B dash, A dash and 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 B dash. Here you can observe. So object is object is real, object is real, image is virtual. Object is real, image is object, object. Object is real, image is virtual. Object is virtual, image is real. And second one, so object distance is equal to image distance. So this is the object, this is the mirror, this is the image. Object and image. Object, 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 object. This is the object and this one is the image. Image, image, and this one is the mirror. Mirror. The distance between object to image, the distance between object to mirror. Object to mirror is called object distance. The distance between mirror to image is called image distance. So image distance denoted with the letter V. Letter V. V. Okay. So object distance is equal to image distance. Object distance is equal to image distance. And height of the object is equal to height of the image. This is the height of the object, height of the image. Height of the object is equal to height of the image. And the fourth one, coming to the fourth one, so magnification of the plane mirror is +1. Magnification of the plane mirror is +1. What is magnification? So height of the image by height of the object. Height of the image by height of the object is called magnification. In plane mirror, only in plane mirror, only in plane mirror. So the magnification is +1. The magnification is +1. And coming to the fifth one, lateral inversion. Lateral inversion. Lateral inversion, lateral inversion. So what is lateral inversion? Lateral inversion is nothing but the phenomenon of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. This mirror image is called lateral inversion, lateral inversion, lateral inversion. Once again. Object is real, image is virtual. Object is virtual, image is real. Object distance is equal to image distance. Height of the object is equal to height of the image. and magnification equal to +1. What do you mean by magnification? Magnification is nothing but height of the image by height of the object, or size of the image by size of the object. So it also shows lateral inversion. What is the lateral inversion? The phenomenon of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. Lateral inversion. Lateral inversion. Lateral inversion. So what is object distance? The distance between object to mirror is called object distance. What is image distance? The distance between mirror to image is called image distance. So what do you mean by magnification is +1? Height of the image by height of the object. Height of the image by height of the object, or size of the image by size of the object. That is called magnification. Magnification is +1. Magnification is +1. Magnification is +1. Yes. Now we are discussing. We are going to discuss about what is that? What is that? We are going to discuss about spherical mirror. 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 Okay. Spherical mirror. What do you mean by spherical mirror? The mirror which in the form of curved surface. The mirror which in the form of curved surface is called spherical mirror. Spherical mirror. Mirror. Spherical mirror. Spherical mirror. Okay. So the mirror which in the form of curved surface is called spherical mirror. So spherical mirrors are two types. Concave mirror, convex mirror, concave mirror, convex mirror. So concave mirror. So what do you mean by concave mirror? The mirror whose reflection takes place inward. The mirror whose reflection takes place inward is called concave mirror. The mirror whose reflection takes place outward is called convex mirror. The mirror whose reflection takes place inward is called concave mirror. The mirror whose reflection takes place outward is called convex mirror. Convex mirror. So here you can observe here. So concave mirror is also known as converging mirror. Converging mirror. Converging mirror. Converging mirror. Converging mirror. Converging mirror. So after reflection, light rays are meeting at one point. So here you can observe. After reflection, those light rays are meeting at one point. Here you can see. You can see here. Once you observe here. So these are the reflector light rays. So here one more thing you can see. So these are the light rays. These are the light rays, reflector light rays, reflector light rays, reflector light rays, reflector light rays. So this mirror is called convex mirror. Why we are calling this is a convex mirror? So after reflection, light rays are moving away from the principal axis. So that's why this is also called diverging mirror. So reflection takes place outward. Reflection takes place outward. Coating will be inward. That's why it is concave mirror. So why concave mirror is also known as diverging mirror? Convex. This is a concave mirror, converging mirror, converging mirror, converging mirror, converging mirror. So here convex mirror, diverging mirror, convex mirror is diverging mirror, diverging mirror, diverging mirror, diverging mirror, diverging mirror. Convex mirror is also known as diverging mirror. Concave mirror is also known as converging mirror. So here when light rays are incidenting on it, after reflection those light rays are moving away from the principal axis. That's why it is called convex mirror, also known as diverging mirror. So now we will discuss about terms related to spherical mirror. Terms related to spherical mirror. Spherical mirror. Spherical mirror, 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 spherical mirror. So here you can observe one thing. So I am taking the concave mirror. This is a concave mirror, concave mirror, concave mirror. It is a part of this sphere, part of this sphere, part of this sphere. So this is the center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part. Concave mirror, converging mirror, concave mirror, converging mirror. Center of the imaginary sphere. Center of the imaginary sphere in which mirror is a part is called center of curvature. The midpoint of the mirror is called pole. Midpoint of the mirror is called pole. The line joining up center of curvature and pole is called principal axis, principal axis, principal axis, principal axis, principal axis, principal axis. Point number 1, center of curvature. Point number 2, pole. Third one, principal axis. Principal axis, principal axis, principal axis, principal axis. After reflection, light rays are meeting at one point on the principal axis. After reflection, light rays are meeting at one point on the principal axis. That point is called focus. 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 After reflection, all light rays are meeting at one point on the principal axis called focus. Principal focus. Principal focus. Or simply we can say focus. Principal focus. Because this focus is on principal axis. That's why it is called principal focus. But simply we can call focus. Simply we can say focus. Okay, so the distance between center of curvature and pole is called radius of curvature. Radius of curvature. The distance between center of curvature and pole is called radius of curvature. Radius of curvature. Radius of curvature. Radius of curvature. The distance between focus and pole. This is called focal length. Focal length, focal length, focal length. That is denoted with a small letter f. Sir, you mentioned here capital F. You mentioned here small f. So why you did like this? So actually here you can observe here, okay. So principal focus, that is called principal focus. Principal focus. After reflection, all light rays are meeting at one point on the principal axis, that is called principal focus. And here you can observe the distance between focus to pole is called focal length. Focal length. The distance between focus to pole is called focal length. Focal length is denoted with a small letter f. Small letter f. I hope it is very clear. Now we are discussing about seventh one. Width of the mirror or reflecting surface. So reflecting surface, here you can see the reflecting surface or diameter of the reflecting surface is called aperture. Aperture. What is that? Aperture. So the diameter of the reflecting surface is called aperture. Aperture. So here you can observe. So center of the imaginary sphere in which mirror is a part is called center of curvature. Midpoint of the mirror is called pole. The line joining of center of curvature and pole is called principal axis. Principal axis. Principal axis. Principal axis. So after reflection, all light rays are meeting at one point on the principal axis. After reflection, all light rays are meeting at one point on the principal axis called focus. 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 Okay, what about radius of curvature? The distance between center of curvature and pole is called radius of curvature. The distance between center of curvature and pole is called radius of curvature. So the distance between focus to pole is called focal length. Focal length. Focal length. The distance between focus to pole is called focal length. And width of the reflecting surface is called aperture. Aperture. So this is about terms related to spherical mirror. Center of curvature, radius of curvature, principal axis, focus, pole, focal length, and aperture. Aperture. So this is about terms related to spherical mirror. So now we are discussing about rare rules of concave mirror and convex mirror. Concave mirror, convex mirror, concave mirror, convex mirror, concave mirror, convex mirror, concave mirror, convex mirror. Concave mirror is converging mirror. Convex mirror is diverging mirror. First point I am taking. Pole, focus, center of curvature. So light ray is coming from infinity. After reflection, it passes through focus. Light ray is coming from infinity. After reflection, it passes through focus. Second one. Pole focus, center of curvature. Light ray is passing through focus. After reflection, it reaches to infinity. Same it is reverse of first one. Sorry. So here you can observe first one and second one both are exactly opposite. You can observe one thing. So here this is a concave mirror. Concave mirror. Light rays coming from infinity. After reflection passes through focus. Light rays passing through focus. After reflection reaches to infinity. Become parallel to the principal axis. And third one. Light rays passing. So pole, focus, center of curvature. Light rays passing through center of curvature. It retraces its original path. And coming to the fourth one. Fourth one is just like reflection. So pole, focus, center of curvature. Light rays incidentting at the pole after reflection, it reflect back into the same medium. So it is just like reflection. Just like reflection. So coming to the next one, convex mirror, diverging mirror. Convex mirror is diverging mirror. Diverging mirror. Diverging mirror. It is diverging mirror. Diverging mirror. So first point I am taking here, you can observe pole focus, center of curvature. Pole focus, center of curvature. Light rays coming from infinity after reflection, it passes through focus. Passes through focus. And coming to the next one. So second one, convex mirror is diverging mirror. Pole, focus, center of curvature. Light rays passing through focus. So here you can see light rays passing through focus. So after reflection, it moves towards infinity. Okay, so coming to the third one. So light ray. So pole, focus, center of curvature. Light ray is passing through center of curvature. Yes or no? So here you can see light ray is passing through center of curvature. After reflection, it retraces its original path. After reflection, it retraces its original path. So here you can observe its light rays passing like this. It reflect back. So here you can observe. So this is about. So light ray is passing along the normal light. Reflect. It retraces its original path. And fourth one. So light rays incidentting at the pole. It reflect back. So pole focus, center of curvature. Pole focus, center of curvature. Light rays incident the pole, it reflect back. Light rays incident the pole, it reflect back. So now you can observe here. You can observe one thing. So light ray is coming from infinity after reflection, it passes through focus. Light ray is passing through focus after reflection, so become parallel to the principal axis, reaches to infinity. Light ray is passing through center of curvature, it retraces its original path, it reflect back into the same direction. Light ray is incidenting at the pole, it reflect back. Light ray is incident at the pole, it reflect back into the same medium. So these are the rare rules of concave mirror and convex mirror. Rare rules of concave mirror and convex mirror. Now we will discuss about image formations. Image formations. Image formations. Image formations. Image formations. So everybody be ready for it. Everybody be ready for it. So here I'm taking the concave mirror. So pole, focus, center of curvature, pole, focus and center of curvature. Object is placed at infinity. Where object is placed? Object is placed at infinity. Image is formed at F. So many light rays are required to form the image of the object. Minimum 2 light rays. Minimum 2 light rays are required to image of the object. So I'm taking one light ray like this. So after reflection, so after reflection, these light rays are meeting at 1 point. Our object is at infinity. Object is at infinity. So object is at infinity. Image is forming at focus. Nature of the image is real and inverted, and size of the image is highly diminished. Highly diminished. Point number one. Coming to the point number two. Pull focus, center of curvature. Pull focus, center of curvature. Object is placed beyond center of curvature. Center of curvature. So how many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. One light ray I am taking like this. After reflection, it passes through focus. So another light ray is passing through center of curvature. So the image is formed between C and F. Image is formed between center of curvature. So between center of curvature and focus. Center of curvature and focus. Object is placed beyond center of curvature. Object is placed beyond C. Image is found between C and F. Nature of the image is real and inverted, and size of the image is diminished. Size of the image is diminished. And coming to the third one. Object is placed at. So full focus, center of curvature. Object is placed at C, where image is forming at C itself. How many light rays are required to form the image of the object? How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Yes or no? Minimum light rays? Minimum 2 light rays are required to form the image of the object. So I am taking one light ray like this. So here you can observe, object is placed at C, image also will form at C. Object is placed at C, image also will form at C. So nature of the image is, object is formed at C. Object is formed at C. Image also, object is placed at C. Image also will form at C. Nature of the image is real and inverted, and size of the image is same size. Nature of the image is object is placed at C. Image also will form at C. Nature of the image is real and inverted, and size of the image is same size. Size of the image is same size. Yes, so same size. Coming to the fourth one, object is placed so between C and F. So pole focus, center of curvature, pole focus and center of curvature. Object is placed between C and F. Object is placed between C and F. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. So I'm taking one light ray here like this. One light ray I'm taking like this, it passes through focus. Another light ray is incident at the pole. So those light rays are meeting beyond center of curvature. Here, beyond center of curvature. Object is placed between C and F. Object is placed between C and F. Object is placed between C and F, where image is formed beyond C. Beyond C. What is the nature of the image? Real and inverted. What is size of the image? Size of the image is large. Size of the image is large. Why it is large? Because object is placed between C and F. So one light ray is passing through focus, another light ray incident the pole, it reflect back. Those light rays are meeting beyond center of curvature. So real and inverted and enlarged. What type of image is formed? Enlarged. So next one, very important. So here you can observe once again, I will explain. So object is at infinity. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image object. How many light rays? Minimum 2 light rays are required to form the image of the object. So here these light rays are coming from infinity. After reflection, those light rays are meeting at focus. So real and inverted, and the size of the image is highly diminished. What is the nature of the image? Real and inverted. What is the size of the image? Highly diminished, because point size image is forming at focus. And coming to the next one, object is placed beyond center of curvature. Image is formed between C and F. What is the nature of the image? Real and inverted. What is the size of the image? Diminished. Diminished. Compared to the object, image size is decreased. So next one, object is placed at C. Image also formed at C. Nature of the image is real and inverted. Size of the image is same size. So here you can see object is placed between C and F. Object is placed between C and F. So image is formed beyond center curvature. Nature of the image is real and inverted. What is the size of the image? LR. Size of the image is LR. Size of the image is large. Now we are going to discuss about next one, fifth one, sixth one. So next one, fifth one. Object is placed at F. Object is placed at F. Fifth one I am taking here. So this is a concave mirror. So concave mirror is nothing but, so reflecting will be inward, coating will be outward. Object is placed there. Object is placed at a pole, focus, center of curvature. Pole, focus and center of curvature. Object is placed at F. How many light rays are required to form the image of the object? Minimum. Minimum 2 light rays are required to form the image of the object. One light ray I am taking like this. After that it passes through focus. So another light ray is passing through, incidenting at the pole, it reflect back. Okay, so object is at F. Image is formed at infinity. Object is placed at F. Image is forming at infinity. Nature of the image is Nature of the image is real and inverted, real and inverted, real and inverted, and size of the image is highly enlarged. Highly enlarged, highly enlarged, highly enlarged, highly enlarged, highly enlarged. So here I am considering like this. So this diagram is very important. So now you can see here. So very important. Very important. So last case, sixth case. Last case, sixth case is very important. Sixth one, sixth one, sixth one. Dun, 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 dun. So pole focus, center of curvature. Pole focus and center of curvature. Object is placed between F and P. Object is placed between F and P. What type of image is forming? Nature of the image is virtual erect and yellow. Virtual erect and yellow. How many light rays are required to form the image of the object? One light ray I am taking like this. It passes through focus. So if you are extending these light rays, where image is forming? Image is forming behind the mirror. So nature of the image is virtual erect and highly enlarged. So we can't say highly enlarged, we can say enlarged. Yes, we can say enlarged. We can say enlarged. We can say enlarged. We can say enlarged. Yes, virtual erect and magnified, and we can say enlarged also. Okay, object is placed between F and P. So image is forming behind the mirror. Image is forming behind the mirror. Okay, behind the mirror, behind the mirror, behind the mirror, behind the mirror. Image is formed behind the mirror. Dun, 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 dun. What is the nature of the image? Virtual, erect, and enlarged. Okay, so this very important 3 marks question can be expected. Okay, so very important, definitely expected question in the board exam. So there are many applications are there on this. Okay, so dentist, so palmist. Okay, so teeth can be observed by using this mirror. So dentist can be used this mirror to observe the patient teeth, and shaving mirror we can use this one. Okay, so very important, this case can be used. Okay, so this is very important, 3 marks question expected in board exam. So try to prepare, try to practice this question. Okay, so yes, so thank you so much for joining, and still it is there. So convex mirror we have to discuss. So if you like the content, if you like the explanation, please do like, share and subscribe to Student the Brand. So this is your Shiva sir from Student the Brand. Okay, so there are many videos are there in my YouTube channel, so just to go and watch those videos. So completely it's related to physics, so especially grade 10 physics, CBSE grade 10 physics. So there are many chapters, light reflection, refraction, so many videos related to CBSE grade 10. So based on 4 chapters: light reflection and diffraction, human in colorful world, electricity, magnetic effects of electric current. So all those videos related to these 4 chapters, like especially those we mentioned, CBSE grade 10. Remaining videos are there, like grade 11, grade 12, and shorts are there related to definitions, and related to conceptual. and questions related to questions also. There are many videos are there. Just go and watch, and you will get amazing content from the channel. Just to go and check once all the videos so related to physics. So definitely you will get the amazing concepts. Okay, so amazing topics so related to physics. Okay, so till now we discussed about, if you like the content, if you like the channel, if you like the videos, so do like, share and subscribe to Student the Brand, and inform your friends, ask your friends to join to the class. So okay, it will be helpful for them to learn the concepts. Okay, so yes. Okay, so now we are discussing about convex mirror. Convex mirror. Convex mirror is diverging mirror. Diverging mirror. Convex mirror is diverging mirror. Yes or no? Yes or no? Yes or no? Yes or no? So here I am taking the convex mirror. So pole, focus and center of curvature. Pole, focus and center of curvature. Object is placed at infinity. Okay, object is placed at infinity. Image is formed at focus. So what is the nature of the image? Virtual, erect and highly diminished. Object is placed at infinity. Image is forming at focus. What is the nature of the image? Virtual, erect and highly diminished. Virtual, erect and highly diminished. So I'm taking one light ray here like this, another light ray is like that. So after reflection, so we are extending these light rays. So we are extending these light rays. These light rays are extended. Those extended light rays are meeting at one point. So here. Sorry, object is at infinity, image is forming at image is forming at focus. Okay, so object is at infinity, image is forming at focus. Nature of the image is virtual, erect and highly diminished. Virtual, erect and highly diminished. Virtual, erect and highly diminished. That is the point number one. Coming to the so this is the pole, focus, center of curvature. Pole, focus and center curvature. Object is placed in front of the concave mirror. So infinite is nothing but between infinity and optics and infinity and pole. Infinity and pole. How many light rays are required to form the image of the object? Minimum. Minimum 2 light rays are required to form the image of the object. So I'm taking like this one, and one more. So I'm taking like this, incidentting at the pole, it reflect back. So if you're extending those light rays, it passes through focus. So here also we are extending this one. So image will form between P and F. Okay, between P and F. So now you can observe object is placed between P and infinity. Image is formed between P and F. Nature of the image is virtual, erect and diminished. Virtual, erect and diminished. Virtual, erect and diminished. Diminished. So here once again, object is placed between P and infinity. Image is forming between P and F. So nature of the image is virtual, erect and size of the image is diminished. Okay. I hope it is very clear. So this is about convex mirror. This is about convex mirror. So just now I explained about concave mirror. Now I'm explaining about convex mirror. So these are the image formations. Image formation. Now I will explain about sign conventions. Very important. Sign conventions. So for a problem, these sign conventions are very important. Just check once. So actually it is a part of this sphere. It is a part of this sphere. So I'm taking pole, focus, center of curvature. So pole, focus and center of curvature. Okay. All measurements will be taken along the direction of incident rays. Along the incident rays direction, all are positive. So in this direction, what are those? What are those? Object distance, image distance, focal length, radius of curvature. All measurements will be taken in the direction of incident rays. All are positive. All are positive. So in the direction of opposite incident rays, all are negative. So in the direction of incident rays, all are positive. Opposite to incident rays, all are negative. Above the principal axis, all are positive. Below the principal axis, all are negative. Sir, what are those? Object distance, image distance, focal length, radius of curvature, object distance, image distance, focal length, radius of curvature. So I'll sing a song, right? New Cartesian, sign convention, new Cartesian, sign convention, all distance measure from the pole, distance are positive along the instant rays, distance are negative opposite to instant rays, distance are positive above the principal axis, distance are negative below the principal axis. New Cartesian, sign convention, new Cartesian, sign convention, all distance measure from the pole, distance are positive along the instant rays, distance are negative opposite to instant rays, distance are positive above the principal axis, distance are negative below the principal axis. New Cartesian, sign convention. So here you can see all measurements will be taken from the pole. In the direction of incident rays, all are positive. Opposite to incident rays, all are negative. Above the principal axis, all are positive. Below the principal axis, all are negative. Okay. So here in this direction, object distance, image distance, focal length and radius of curvature all are positive. So opposite to incident rays, object distance, image distance, focal length and radius of curvature all are negative. Above the principal axis, height of the image and height of the object both are positive. Below the principal axis, height of the image and height of the object both are negative. So this is about sign conventions. Okay, so I hope it is very clear. So next, so we will discuss about mirror formula. Mirror formula. La 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 la. La 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 la. La la la. La 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 la. La la la. Mirror formula 1 by f equal to 1 by v plus 1 by u. Magnification equal to, so minus v by u. That is nothing but height of the image by height of the object. So mirror formula. What is mirror formula? 1 by f equal to 1 by v plus 1 by u. So magnification equal to minus v by e, height of the image by height of the objects. I hope it is very clear. So I hope it is very clear. This is about mirror formula and magnification. Okay. So next, so we'll discuss about refraction, 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 refraction. So when light ray is passing from one medium to another medium, so you can observe here. So this is the rarer medium, speed of light is more. This is the denser medium, speed of light is less. Best example I am taking air and water. So air and water. So now I am talking about refraction. Refraction, refraction. So light ray is moving from one medium to another medium. Yes or no? So if the light ray is moving from one medium to another medium, so this is incident ray, this is the normal line, and this one is the refracted ray. So refracted ray, refracted ray. So the distance between incident ray and normal line is called angle of incidence. Angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. Okay. So angle between incident ray and normal line is called angle of incident. Angle between refracted ray and normal line is called angle of refraction. So next one, if the light ray is passing from rarer to denser, so denser like this. So like if you are taking light ray is moving from denser to rarer. So rarer to denser is here like this. If the light ray is passing from denser to rarer, how it will be? So here you can observe. So this the angle between incident ray and normal line is called angle of incident. Angle between refracted ray and normal line is called angle of refraction. So in case 1, so in this case you can observe, in this case angle of incidence is greater than the angle of refraction. Point number 1. So why sir? Why you are saying angle of incident is greater than the angle of refraction? Because when light ray is moving from rarer to denser, the speed is decreasing in the denser medium, so it bends towards the normal line. So if it is bending towards the normal line, the angle is decreasing compared to angle of incidence. So angle of incident is greater than the angle of refraction. And in this case, in the second case, case 2, angle of refraction is greater than the angle of incidence. Angle of refraction is greater than the angle of incidence. Why? So when light ray is moving from denser to rarer, speed of light is increasing. That's why the light ray is moving away from the normal line. So this is angle of incident and angle of refraction. So angle of refraction is greater than the angle of incidence. So these 2 points are very, very important. Very, 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 very important. So what is refraction of light? The path of the light changes at the interference of the two media. So that is called refraction, or bending of the light ray at the interference of the two media is called a refraction, or the direction of the light ray changes at the interference of the two media, that is also known as refraction. Refraction. So if the light ray is moving from rarer to denser, it bends towards the normal line. If the light ray is moving from denser to rarer, it moves away from the normal line. So what is the reason behind of it? So here, so in the rarer medium, speed is more when it is coming to the denser medium, so speed is less, so refractive index is more compared to so rarer medium. In denser medium, refractive index is greater, so this point also very important. So refractive index of denser medium is greater than the refractive index of rarer medium. Okay, in this case, same thing will be there. So refractive index of denser medium is greater than the refractive index of rarer medium. So that's why, so light ray is bending towards the normal in the denser medium. So in this case, light ray is moving away from the rarer medium, so away from the normal line in the rarer medium. I hope it is very clear. So now we are discussing about so Snell's law or laws of refraction. Snell's law, laws of refraction. So I'm taking this a normal line. So this is the incident ray, refracted ray. Angle between incident ray and normal line is called angle of incident. Angle between refracted and normal line is called angle of refraction. Snell's law, what are those? So first one. So incident, Snell's law are laws of refraction. So Snell's law are laws of refraction. So here first point is incident ray, refracted ray, normal line. This is the incident ray, refracted. Incident ray, refracted ray, normal line lies on the same plane. So that is the point number 1. Coming to the point number 2, the ratio of sine of angle of incidence to sine of angle of refraction equal to constant. The ratio of sine of angle of incident to sine of angle of refraction equal to constant. So the ratio of sine of angle of incident to sine of angle of refraction equal to constant, that is nothing but refractive index. So n equal to sine I by sine r. So that is nothing but refractive index. So what is absolute refractive index? So ratio of speed of light in vacuum by speed of light in medium is called absolute refractive index. So next one, so n12, that is nothing but n1 by n2. So we can also write v2 by v1. Sir, why you are writing v2 by v1? So here you mentioned n equal to c by v, right? So absolute refractive index. Absolute refractive index is nothing but speed of light in vacuum by speed of light in medium. Speed of light in vacuum by speed of light in medium. Understood? So n equal to c by v. So with respect to speed of light in vacuum, so if you are taking the medium, then that is called absolute refractive index. Coming to relative refractive index is nothing but so speed of light in medium 1 by speed of light in medium 2. So in these two mediums, so one medium should not be any one medium should not be air or vacuum, or so other than air or vacuum we have to take two mediums. Okay, so refractive index of medium 1 by refractive index of medium 2. So our v, if you are taking n1 by n2 equal to v2 by v1, n1 by n2 equal to v2 by v1. Okay, so this is about relative refractive index, this is about absolute refractive index and relative refractive index. So this also we can write n21. So n2 by N1 equal to V1 by V2. V1 by V2. So N is inversely proportional to velocity. N is inversely proportional to velocity. So that's why I'm taking N equal to C by V. N equal to C by V. Absolute refractive index. Coming to relative refractive index. N12. N1 by N2 equal to V2 by V1. So N21. N2 by N1 equal to V1 by V2. So this is about. Okay, now absolute refractive index and relative refractive index. Sir, what is refraction? So the bending of the light at interference of the two media. So what are the laws of refraction? Incident ray, refracted ray, normal line lies on the same plane, and the ratio of sine of angle of incidence to sine of angle of refraction equal to constant. That is nothing but refractive index. That is nothing but n. So absolute refractive index equal to n equal to c by v. N12 equal to n1 by n2. That is nothing but v2 by v1. N2 by n1. That is nothing but v1 by v2. So this is about laws of refraction. I hope it is very clear. So next, glass slab. So here I am taking like this. This is a glass slab. So one is rarer medium, another one is denser medium. So this is a rarer medium, denser medium. So be careful. So if the light ray is passing from rarer to denser, at the interference of the two media, at this point, the light ray will bend. So like this. Okay. So here. So if you are extending this light rays, okay, so this is about incident ray. Incident. Initial direction of the incident ray. So the distance between emergent ray and initial direction of the incident ray. Angle between incident ray and normal is called angle of incidence. Angle between refracted and normal is called angle of refraction. And angle between emergent ray and normal is called angle of emergence. So the distance between emergent ray and extended initial direction of the incident ray is called lateral shift. Initial direction of the incident ray. The distance between emergent ray and initial direction of the incident ray is called lateral shift. What is that? Lateral shift. Sir, so lateral shift is okay, sir. What about vertical shift, sir? Vertical shift. So now you can see here. So I am taking the beaker. This is a beaker. Okay, so the person is standing over here. The person is standing from here. So he is observing the coin is placed. So I am placing the coin at the bottom of the beaker. So this is the coin. So this is the coin. Okay. So he can't able to see the coin. Okay. From this position. So he can't able to see the coin. So after pouring water, the coin position rises up. Here until here. The coin position rises up here. Okay. So the distance between actual position to apparent position of the coin is called vertical shift. The distance between actual position to apparent position of the coin is called vertical shift. I hope it is very clear. So incident ray, refracted ray, emergent ray, So the distance between emergent ray and initial direction of the incident ray is called lateral shift. Lateral shift. So and the distance between actual position, this is a coin. So this is a coin position. So this is the actual position of the coin, and this is the apparent position of the coin. After pouring water, the coin position rises up. Okay. So this is actual apparent position. Apparent position of the coin. Apparent position of the coin. Okay. So apparent position of the coin here. Actual position of the coin. Apparent position, just you can mention apparent position, and your actual position of the coin. So anyway, we'll mention the coin. Okay. So I hope it is very clear. This is the actual position of the coin. So okay, so these are the points. Next, so I'm taking the beaker like this. This is the beaker. Okay, so I pour the water here. So if you place the pencil. So if I'm placing the pencil, so like this. So the position of the pencil appears to be bent, but actually it is not bent. So it appears. So here it is like this. So it appears bent. Actually, this is a position. Understood? So due to refraction of light. Due to refraction of light. So I hope it is very clear. So when light ray is passing from rarer to denser, it bends towards the normal line. If it is passing from denser to rarer, it moves away from the normal line. So okay. So next one. And even if you place the lemon, if you place the lemon inside of the beaker also, it appears bigger. So if you're placing the lemon like this, if you are placing the lemon also it appears bigger. Lemon, due to refraction of light. Refraction of light. Tin, 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 tin. Na ni ni na ni na 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 ni na ni na la 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 la. Okay, so now, so one more concept, that is critical angle and total internal reflection. Critical angle and total internal reflection. Okay, so this is a rarer medium, denser medium. Light ray is passing from rarer to denser. Rarer to denser. So light ray is moving like this. So angle between incident and normal line is called angle of incidence. Angle between refracted and normal line is called angle of refraction. What is that? Angle of refraction. So here you can observe at this position. So from this point I am taking light rays like this, like this. So at certain point of angle of incident, angle of incident, right? Yes. So you can see, you can observe your distance. So this is 90 degrees, 90 degrees. So here you can observe. So I'm taking light ray like this. Okay. So I'm sending the light rays. So like this, and here also like this, and here also like this. So and keep on sending the light rays. At certain angle of incidence, the refracted ray passes along the normal line or gauges along the normal line. So passes or gauges or moves along the normal line. Okay. So at certain angle of incidence, the refracted ray passes or gauges or moves along the normal line. That is called critical angle. So now you can see the light ray is moving from your denser to rarer. So like this. Okay, so it is making the refracted ray making more than 90 degrees. So here 90 and this also theta. So more than 90 degrees. Then refracted ray will be reflected back. Okay, or so this will be reflected into the same medium, into the denser medium. Okay, so refracted ray makes more than 90 degrees, then it will be reflected back into the same medium. So this phenomenon is called total internal reflection. So light ray is moving from denser to rarer. So in the rarer medium, it is making more than 90 degrees with the normal line. Then it reflected back into the same medium. So this phenomenon is called total internal reflection. Okay, light ray is moving from denser to rarer at certain angle of incidence. At certain angle of incidence, the refracted ray passes or gauges or moves along the along the surface, that is called critical angle. The angle at which the refracted ray passes or gauges or moves along the surface is called critical angle. Okay, so that's enough. Next one. So we'll discuss about lenses: convex lens, concave lens, convex lens, concave lens. So convex lens is also known as converging lens, concave lens is also known as diverging lens. So I'm taking here this a convex lens. So optic center. So F1, 2F1, F2, 2F2. So this side I'm taking 1, that side I'm taking 2. So do like, share and subscribe to Student the Brand. If you like the content, if you like the channel, if you like my explanation, please do like, share and subscribe to Student the Brand. So here I'm talking about convex lens. Okay, so light rays are coming from infinity. So one light ray I am taking like this. So another light ray I am taking like this. After refraction, those light rays are meeting at focus. Okay. So convex lens is also known as converging lens. Convex lens. This is a convex lens. Convex lens is also known as converging lens. Whereas concave lens is also known as diverging lens. Okay, so optic center F1, 2F1, F2, 2F2. So this light rays. So whenever the light rays are incidenting on it, so like this I'm taking, those light rays are moving away from it. And here also these light rays are moving away from it. Okay, so if you are extending the refracted light rays, those refracted light rays are meeting at focus. So that's why this lens is also known as diverging lens, because when now the light rays are incidenting on it, after refraction, those light rays are moving away from the principal axis. Here you can observe, after refraction, those light rays are coming closer to the principal axis. So convex lens is also known as converging lens. Concave lens is also known as diverging lens. Now we will discuss about ray rolls. Ray rolls we'll discuss. Okay. Convex lens. Optic center F1, 2F1, F2, 2F2. So light ray is coming from infinity. After refraction, it passes through focus. Light ray is coming from infinity. After refraction, passes through focus. Point number 1. So light ray is coming from infinity after refraction passes through focus. Point number 1. Coming to the point number 2. Optic center F1 to F1, F2 to F2. Light ray is passing through focus. So it is moving towards infinity parallel to the principal axis. Coming to the next one, third one. So light rays optic center F1 to F1, F2 to F2. Light rays passing through optic center, no deviation takes place. It won't deviate. Okay. So if the light ray is passing through optic center, no deviation takes place. It passes like that. So this is about convex lens. Coming to concave lens. La 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 optic center F1 to F1, F2 to F2 to F2. Light ray is coming from infinity after refraction. After refraction it diverges, it passes through focus. So here also light ray is passing through focus. Optic center F1 to F1, F2 to F2. Light ray is passing through optic center. So light ray is passing through F2. Light ray is passing through F2. So after refraction become parallel to the principal axis and moves towards infinity. And last one. So optic center F1 to F1, F2 to F2. Light ray is passing through optic center. So no deviation takes place. It moves towards, so without any deviation it passes. I hope it is very clear. So these are the ray rules. Image formations. So be ready for it. Image formations. Object is placed at infinity. Object is placed at infinity. Image is forming at focus. Yes or no? Yes or no? So here I am taking this a convex lens. Optic center F1 to F1, F2 to F2. So how many light rays are required to form the image of the object? How many light rays? Minimum 2 light rays are required to form the image of the object. Minimum 2 light rays are required to form the image of the object. So one light ray I am taking like this. Another light ray I am taking like this. After refraction, those light rays are meeting here. Okay. So object is at infinity. Image is formed at F2. Nature of the image is real and inverted. Size of the image is highly diminished. Object is placed at infinity. Image is formed at focus. Nature of the image is real and inverted, and size of the image is highly diminished because it is point size image is formed at focus. That is the first one. Coming to the second one. So optic center F1 to F1, F2 to F2. Object is placed beyond to F1. Object is placed beyond to F1. So I am placing the object here. Okay. So one light ray I am taking like, so here one light ray I am taking like this. After that it passes through focus. Another light ray is passing through optic center. Those light rays will meet here between F2 and to F2. Okay, between F2 and to F2 the image will form. So object is placed beyond 2f1, image is forming between f2 and 2f2. Nature of the image is real and inverted. Object is placed beyond 2f1, image is forming between f2 and 2f2. Nature of the image is real and inverted, and size of the image is diminished. So diminish. Next one, object is placed. Third one, object is placed like this. So here I am considering like this. Optic center, focus, 2f1, f2, 2f2. So object is placed at 2f1. So I am placing object where object is placed at 2f1. How many light rays are required to form the image object? One light ray I am taking like that, passes. Another light ray is passing through optic center. The light rays will meet. So here, object is placed where object is placed at 2f1. Where image is forming at 2f2. Object is placed at 2f1, image is formed at 2f2. Nature of the image is real and inverted. Size of the image is same size. Okay, same size. So next one. So fourth one. So optic center f1, 2f1, f2, f2, 2f2. Okay, so object is placed between 2f1 and f1. How many light rays are required to form the image of the object? Minimum 2 light rays are required. Yes or no? One light ray I am taking like this. It passes through focus. So another light ray is passing through optic center. The light rays will meet. Okay, so here how many? So image formations, 4 image formations. Okay, so next 2 more image formations are there. So be ready for it. 2 image formations. So convex lens. So 5th image formations. 5th one. Optic center f1, 2f1, f2, 2f2. Object is placed at f1. So one light ray I am taking like this. It passes through focus. Another light ray is passing through optic center. So object is at f1. Image is forming at infinity. Nature of the image is real and inverted. And the size of the image is highly enlarged. Size of the image is highly enlarged because image is formed at infinity. Okay. So next one, sixth one is very important. Sixth one is very important. Focus on it. Very important. So be careful. Okay. So ready. So convex lens, optic center f1, 2f1, f2, 2f2. Object is placed between f1 and above. So one light ray I am taking like this. It passes through focus. Another light ray is incident at the pole. Optic center. Okay, incident at the optic center. Okay, so now we are extending these light rays. Are you understanding or not? Just click on like button. If you like the channel, if you like the content, if you like the explanation, just click on like button. No, just click on like button. So at least it gives me boost, energy, everything. Yes, just click on like button. Just click on like just how like that. Okay. So if you are extending. So here I am taking like this. So here I am considering like this. Object is placed between F and O. Image is forming same side of the object. Nature of the image is virtual, erect, and enlarge. So that just please click on like button, do like, share, and subscribe to Student the Brand. So please support my channel, encourage my channel, and so share to your friends as much as possible, as many as possible. So please spread a word regarding the Student the Brand. So it is completely dedicated for physics. So I need your support. Support my channel. So share as much as possible, share to everyone, inform to the students, ask them to join to the class. So because live classes are going on, important concepts are teaching. Okay, so it is a crucial time to prepare, practice. So if you support this channel, so it will be helpful to the students indirectly. So from you, so thank you so much for supporting, and those who are subscribed and liked and shared my channel, thank you so much. I'm grateful for that. So still those who did not subscribe, please subscribe my channel, share to everyone, and just please click a like button, so it will be helpful to me to reach maximum students. So it's a request for me, please click on like button whenever you are joined to the class. That is like attendance for students, and for remaining students it will be helpful for me to reach maximum students in the live class, right? Yes, thank you. Now object is placed between F1 and O. Image is formed same side of the object. Nature of the image is virtual, erect, and enlarge. Virtual, erect, and enlarge. So very very important. So this case. So make sure that you are practicing all these points. So I hope it is very clear. Next one, concave lens. Only two image formations are there. So please do like, share, and subscribe to Student the Brand. Okay, so this is a channel completely dedicated for physics subject. Okay, so please encourage the channel, subscribe, and so share to your students, those who are so studying grade 11, grade 12, and those who are known so nearby and here. So those are studying grade 11, grade 12, grade from 6 to 10th also, it will be helpful because these concepts are very helpful. You can check once. So videos are there in the channel. Those are related to right from 6 to until 12th. So it will be helpful for every grade. So especially live classes what I'm teaching, that will be helpful for grade 10. So CBSE physics. Okay, so those are studying in CBSE grade 10 physics, CBSE curriculum. So grade 10 students. So send to them. It's completely related to physics. Okay, so in-depth knowledge will be given. So topic to topic, concept to concept, related to concept, what type of questions they will ask in the exam. So where they will ask, so how they will ask, how to answer, how to remember the concepts. So like that, so extraordinary tips will be given in the class. Okay, how to remember the concept, how to recall the concept, and how they will ask, how to answer to particular question, what to write, what answer we have to write to the particular question. Everything will be guided and given proper tips, so this can be implemented so as soon as possible, and whenever exam comes, immediately it will be helpful. Okay, so even once you listen the class, immediately you will understand the concepts. Okay, so it will be helpful for the students to recall. Okay, recall immediately, and remember in a easy way. Okay, so much more easy way, and they can recall and retrieve the information immediately as soon as they want they want to express either oral or written. Okay, so thank you so much. So this is about object. So optic center F1. So to F1, please share to so known friends. So if you are a student, so share to your friends. If you are a parent, please support my channel. So share to your younger ones. Those who are studying in six, right from 6th, 7th, 8th, 9th, 10th, 11th, and 12th, and those who are writing for competitive exams, JEE, NEET, for them also it will be helpful. So parents, I am requesting, please share this channel to everyone, and students, so share to your friends, support my channel, reach maximum number of students. Okay, so I am doing my work from my end, so with my level best. Okay, so please, so it's my request, so please, it's my request, so support my channel, share to as much as possible, as many as possible, and subscribe my channel, those who are there, those who did not subscribe till now. Thank you so much. Okay, so one lighter I'm taking like this, so it will be diverge. Another lighter I'm taking like this, so it is moving away from it. So if you are extending these light rays, okay, so though if you are extending these light rays and these light rays, so the image will form at f1. The image will form at f1. So object is placed at infinity, image is forming at f1. Nature of the image is virtual, erect, and highly diminished. So because image size is point size, it is formed at f1. And coming to the next one. So optic center f1, 2f1, f2, 2f2. So object is placed anywhere between optic center and infinity. Optic center and infinity I am placing here. So one light ray I am taking like this. After that, so it diverging. Another light ray is passing through optic center. Okay. So here, so the image will form between f1 and O. The image will form between f1 and O. Object is placed between optic center and infinity. Image is forming between f1 and O. So nature of the image is virtual and erect, and size of the image is diminished. Okay, diminished. So this is about concave lens. Concave lens. Right now, so we can see here directions we can take. Now we will discuss about power of lens. The reciprocal of focal length is called power of lens. The reciprocal of focal length is called power of lens. P equal to 1 by f, or the simply we can say the degree of so simply we can say reciprocal of focal length. So definition, if you want to write definition, so the degree of converging or diverging of lengths achieved. The degree of converging or diverging of lengths achieved is known as power of lengths. So P equal to 1 by f. SI unit of power of length is diopter. SI unit of power of length is diopter. P equal to 1 by f. So SI unit of focal length is meter. SI unit of power of length is diopter. Okay. So power of lens is positive for convex lens. Power of lens is negative for concave lens. Power of lens is positive for convex lens. Power of lens is negative for concave lens. Okay. And a lens formula is 1 by f equal to 1 by v minus 1 by u. Okay. And a magnification is height of the image by height of the object, that is nothing but v by u. Okay. So this is about lens formula and magnification. So mirror formula 1 by f equal to 1 by v plus 1 by u, and magnification is height of the image by height of the object, that is equal to minus v by u. And here, so the difference is, so this is lens, and this is for mirror. So mirror, so you can observe the difference. So 1 by f equal to 1 by v plus 1 by u, and magnification is height of the image by height of the object, but minus v by u. So this is for mirror and this is for lens. So in the first one, it is positive. Mirror formula is positive, lens formula is negative. In the second case, in mirror, negative value will come. So here positive. Okay. So that is the difference. So remaining everything is same. So mirror and lens like formulas. Okay. So that's enough. I hope uses. So uses and remaining points, few more are there. Those we will discuss. Okay, in the remaining classes. So coming classes, there are many classes are going on. So do like, share and subscribe to Student Brand. So thank you so much for supporting. So thank you so much. So from my bottom of heart. So do support my channel. So let me reach maximum students so that I can spread, I can share my knowledge with everyone. Okay. So if it is helpful, if this channel is helpful, if my explanation is useful, if the content is good, if my explanation is good, so let me reach maximum students. With the help of you only I can able to reach to the maximum students. So by, with your support, with your encouragement, with our no what we can say, uh, unbreakable unbreakable, unmatchable, extraordinary support, with that only I can reach to the maximum student. Please subscribe my channel, share to my channel, share my videos to the no to whomever it is helpful. You can share these videos to everyone. Thank you so much. We'll see you in the next class. So thank you.